First and foremost here, here's what we're going to be covering. We're going to do first, second derivative test, do the critical points and inflection points. We're not graphing. We're not setting up that huge table thing, because today's goal for your homework is just get a little more practice. Can we find those numbers quickly? The potentials. Now, I say potentials because, like yesterday, we talked about some of them where, you know, let's say we're looking at a graph. Let me draw this. So let's say we're looking at a graph, and the problem does something like this. On the original graph, let's say it's like a cubic function. This will show up as a critical point on the actual, like when we do the first derivative. The problem is it's not actually a critical point because it didn't switch directions. It's not a max or a min. It just happens to be a point where the slope went to 0 for a few seconds and then it changed back to positive again. That isn't technically a critical point when we test it.
That's why we gotta test it.
Yeah, and we're not testing anything today. I just want you to get those potential numbers. So that's a potential that will show up when we do the first derivative test. So I got one example. I'll show you how to do it really quickly to do both the first and second derivative. When we're done, you get to go work on your homework, and it's due on Friday. Okay. 6 problems. Okay, let's do the shortcut here. So let's work through it. So this is my sole problem today. If we would like to do another one, I'll do it now. I did throw in some kind of tricky ones in there. So we're going to use those as like talking points maybe tomorrow or Friday. Okay, so don't feel like they're always going to look like this. They're not. I switched up the problems a little bit. I threw a couple where you have to know how to take the first derivative, like an e or a natural log, where you have to do like logarithms and stuff to find values. We've practiced logarithms enough, you should be able to solve for them. Okay, you set them equal to 0, solve. Okay, all right. So on this particular problem, critical points, let's do that first. I'll try to keep these color-coded. Critical points is where you do the first derivative. And again, we are not testing these. We're not graphing. We're doing nothing. We're just finding the potential numbers. I can't stress that enough. So first derivative, what do we get?
12x cubed minus 12x squared.
Good. Minus 12x squared. Okay, so now, if we're going to figure out what the actual like critical points are, you have to factor this thing apart. That's the part that some people forget. You do need to factor and know how to factor this thing correctly so that we can list off what my potentials are. So on this one, I'm going to pull out the 12. I'll pull out an x squared because those are the common factors, right? So when I pull those objects out, I'm left with an x and a minus 1. Again, the item that's in the parentheses should be the same size as the item we started with. The item we started with was a binomial, so I better have a binomial in that parenthesis. A lot of people forget the 1. They just forget you need to put a 1 back there. So it's x minus 1. Now, that means for my potentials here, this item here, since it has a variable on the outside, is 0. And this item here is a 1. Again, it's always the opposite. Now, if you don't know how, you just set each of those pieces equal to 0. That's all you do, and then you solve for it. Okay, that's how I'm getting those numbers. All right, questions?
No.
Okay. All right, let's go to again, those are the critical points. Those are the two numbers I want. So when you answer your question, you say critical points are this and this, right? So it's 0 and 1. I move on to the next problem. Now I'm going to do the inflection points. Same thing. So on this one, we have to take the second derivative. So second derivative on this case, we go off of the first derivative and you keep going. So it'll be 36x squared minus 24x. That's the second derivative of that. Now again, how I got that, I'm going off of the first derivative and just going one more step. Okay. So now, if I factor this thing apart, because again, we do need to factor. Factoring is how we find those potentials. So on this one, I'm going to pull off, a 12x again? Something like that? I think that's what they have in common. A 12x. So that's leaving me with 3x and a minus 2. And I think that's what we're left with when we pull out a 12x. So again, there is a variable on the outside, so my potentials here for the inflection points, again, inflection where it goes from concave down to concave up. So in this one, it would be 0. And this one over here would be a positive 2/3. Now, if there was no x out there and it was just a 12, you ignore it. That doesn't count. It has to have a variable on it. Okay, are we good with what you have to type? All I want are the numbers, the potentials. So you say in your little like answer, critical points are 0 and 1, inflection points are 0 and 2/3. Move to the next problem. We good?
Perfect.
Go ahead and do it. It's on Google Form. I think it just went live about 2-3 minutes ago. I'll make sure if it doesn't show up, I'll just hit submit. I'll just cancel the scheduling. Now, here's the idea. There is a couple tricky ones in there. Out of the 6, I think there's 2 that are kind of tricky. We might use those as talking points maybe tomorrow or Friday. Okay, so today was just an intro. You can get going into there. I think there's 2 problems in particular. All you have to find is critical points on 2 of them. So find the first derivative and do the critical points. So again, factoring is going to be the downfall for most people. Like, oh man, I don't know how to factor. So that will be the trough. It's not in there yet? Okay. All I have to do is cancel. I don't know what time it went live. I forget what time I scheduled it for.
Or will you take
I
back
still
that
don't know how to
with your
factor if
buttons?
there's a number in front.
You're not pushing my buttons anymore. Does that count?
No, I want to
I pushed them.
I'm not apologizing for you eating pizza in my room.
You brought food and didn't share. That's why he's mad.
What? Can you seriously show me how to factor when there's a number in front of X? I literally don't know how to do it. Not like up there, I just mean like on the board.
Oh, a trinomial.
Yeah.
Word, are you mad? Do you want to bite this?
No, I already ate pizza.
It's the same thing.
2 methods. Word is pretty easy.
You want like a trinomial? What do you want?
I'm sorry.
I don't know how to check it.
No, my bad.
COVID party.
Where'd you get that pizza?
I don't know.
Try that at Quick Start.
I don't know. Let's see.
30.
But again, it's been cooked since
28.
10 a.m.
Correct.
Oh, something like that?
It's slow cooking.
Yeah.
It's a slow
Factor
cooker.
it? Then you want me to factor it?
Yeah, I don't know
Okay.
how to do it.
Well, what is this to start with?
I'll try to do it.
Okay, so you probably got to use trinomial rule, right? Unless there's a common factor, it doesn't look like that ever
Why do we have
counts.
to use
So in this case, I'm gonna just do my so I'm gonna instead of equal 0, and you do like e's both logs of both sides. Just do the normal. So, all right. So we factor this. So this symbol means they're going to be the same operations. They're both plus signs. Then we bring up the 3x squared. So 3x and 1x. Right? You bring up the 10 in the back. What options we got? 2 and 5. 10 and 1. Let's go 2 and 5. And then you FOIL it and see if it gives you that, and it does.
Oh.
Oh.
That was not in our notes.
Okay, that's not. Okay.
You better put mask on, sir. Hold on.
That's what I'm trying to find out right now.
Why do you have to wear a mask? You already have it.
Yeah.
Alright, let's give it now.
Yeah, is there supposed to be an X in that problem?
Yeah, there should be an X on that 16. Let me go type that in. I forgot the X on the 16. Sorry, I'll fix it. Hold on.
I also. It's okay,
Okay, hold on.
Ward, if you don't apologize, I'm gonna go home and cry. Like, for
Oh no, don't care.
Oh yeah, you think you're funny or something? Whoa.
I'm hilarious.
And then not X squared, just one over X. Let's take this outside. Well, actually, that makes sense.
You can't even.
And you. That is a challenge.
You can fight with the derivative on the inside.
No, I definitely got money on board.
How do you fight? One of the first one? Oh, I got
it.
You have money on?
No.
I got money on board, dude.
I just got -8.
I don't know. I feel like in a fight.
No, look at him. This man has no fight in him.
Really don't.
Look at him. He would lay down. He's gone.
I'm not a fighter.
You and Matt and Frank going at it. Who you got?
Me.
I definitely have Ward. Definitely have Ward.
What do I do for that? I don't know.
Matt Frank is a beta.
That's offensive to me.
He's a beta.
Oh, I thought you said he's a baby. I'm like, that's offensive.
There's an X on the 16. Sorry, on that one problem. Sorry. If you hit refresh, it'll show up.
Would you agree with the hot take that Matt Frank is
No,
a
you wouldn't
beta?
have to. So it's already factored apart.
It's not even a hot
So
take.
You have like 3 of those.
It's really not.
You have-
Everybody agrees.
This would be a 0. So then you can read all the critical points, right?
I have a question.
So it would be, so you got 2. So I don't know, is this is there a 4 out front? What
Yeah,
was
there's
it?
a so that's nothing.
Yeah, that's nothing. And then what was back here? 12x?
3x.
3x squared.
3x squared is 0.
Okay, that would be a 0. Then you have 3 of these, right? So you have 3 of those, and so these would each have their own critical point
7 up front.
because you can factor that from the
the
part,
power derivative of the inside.
like the inside.
Why can't I just take the cubed root of 8? It's 2.
No. The idea is that you're not taking the. Well, I guess you could technically do that. Yeah, because if you set it equal to 0, I wasn't actually doing that. I was thinking of like actually, yeah, it'd still work out to be the same.
So,
Okay,
plus
so
2 minus
this.
2?
Yeah. No,
Yeah,
just plus.
Ward.
Mr. Ward,
Just be plus 2.
Ward. I know what I would say to you if I wanted.
I just outsmarted Ward.
Ward, if I wanted to be unfair.
Because I was thinking like you can factor that using cube rule.
So it'd be.
And so it should still be 2.
I know exactly how to
3 separate things.
It'll be.
what? This is what
Plus,
graph looks like.
wait, wouldn't it be plus 2 minus 2 plus 2?
No, it would be it would just
That's
be
just Nike.
it'd
just
be
be x minus
just be
2,
x
x
plus
plus
2,
2,
x plus 2, and then there'd be a trinomial behind it.
Yeah,
Which you just ignore that one.
Whoa, is the guy that invented.
I'm not following.
Like how you factor a cube rule. Like if I was gonna factor this thing apart,
So
this is what it
What's
is.
the opposite of one of those?
That's just going to be at 0.
It's this thing squared, it's the opposite symbol, it's these two multiplied together, this thing squared.
So,
Like if I wanted to.
Like that's the
What
factoring
critical
of that
point?
thing.
There's no critical points.
So then you just
ignore it?
Yeah, you ignore this because there's no way to make this thing
5
0.
minus 3.
Hey, we're doing his problem, start doing our problem.
Which is.
I know.
I already did that.
Ward.
I put no critical points, no
Critical
inflection
points?
points.
That one would be 0,
Why
right?
is it 2 though?
And then you just set this thing equal to 0, and you find what the.
What? No,
Factor
right there.
apart, this is equal to 0, and then just solve
It's
for
literally
it.
right there.
Does not exist.
I can put it in.
Like drag the 9 across and take the square
We're
root.
looking for, what is it called? Critical points, one is 0.
Is it the same thing for the second derivative Ward?
9 across, root of
Isaac,
9.
that's a cool white.
You don't need the 7. I mean, you divide the 7 go away, right?
7 goes away,
And then-
and 6 doesn't matter.
Then you take the 6 root of 0, which is 0.
So 3 and
Oh,
0.
I know.
Ward.
Eric, what's your second? 6
Equal
root of
9, take the square root, so it'd be plus or minus what, 3?
We don't need.
Eric, what was your second one?
What? Plus minus 3.
Oh,
How could it be?
Are you on the-
0 and plus minus.
I have no clue. Differential.
It says that it can get away.
You do it probably.
Derivative said it can get away.
I had to type
Why,
in
it's
like
plus 3 and minus 3, by the
Yeah,
way.
my computer before you go.
I think it's a 9.
I don't know.
I think it's a 9.
I don't think that's the 0 thing.
Yeah, it is.
Could you come real quick?
Or can I type it in like this?
So how do we just put 0 colon 2?
Jamie, did you
When
see
you
the
do
one
a
that's
derivative
x
of natural log, that's 1 over
squared?
x.
So
Would you
1
do
over
x
squared.
Are you on that one?
X and
There's
then.
not
There's still a 3 on the
inside.
Oh,
Yeah,
so
so what
it's
you do is
7
Because there's a 3 on top.
x plus 3 x
Yeah.
plus.
Yeah, 3, right?
And then would it just be 5? Times 12?
Yeah.
Where am I?
5 minus.
How do I type
Because it's just a plus right between them. There's a minus right between them.
Yeah.
5 minus
And then
Oh,
it would
okay.
be.
Then if you want to figure out the critical point, just set it equal to 0 and solve.
You want to know
But,
exactly what I
right,
told you.
point 6, then you multiply the x across, and it cancels out.
Alright.
I put 0 times 0 is 0. It doesn't work at all. I was right,
Then you
there are
find
no critical points, they don't exist.
You're like already on the verge.
So, but then I don't. Which one? X equals.
Nah,
This one.
I'm too level-headed for that, I think.
I want it.
I would probably make some jokes, and then I'd get myself in trouble.
Well, I wanna- hey, can we do the, it's the blank for me?
Hmm?
Have you ever seen on TikTok, they go like,
But you don't take x
they
times
go
0
like,
first.
so they say it's the blank, and then you fill it in.
Okay,
So,
Like a quality that they have,
Like,
like.
a lot of teachers and students are
this,
this.
so what's your step?
I don't know what that is.
Like it'd be, if I was doing Travis, it'd be it's the loving attention for me.
You
See?
either multiply it on
And that's
0,
that's
and it
him
cancels,
roasting me.
or you
and
divide
I'd be
by
like,
0, which doesn't exist.
We
It
put
doesn't
on.
happen.
I don't know, I'd be like,
Put a.
Math error.
it's the wannabe frat
over
boy
here.
for me.
Right.
You can't.
Except
I've never heard of this.
Yeah, like mini roast.
No.
Will you do it with me, please? It's like a big
Mathematically, and then
teacher-student
this
thing, like a lot of
goes
money
away.
going around.
Paul,
No.
you did
Put
it.
this
Why not?
over here.
Paul's
These
needed
things
so much.
cancel out.
That's funny.
That would be fun.
Did you?
Here, I'll start.
Glasses.
I'll start.
I'm still factoring it.
Go ahead.
Oh. And then.
Okay, we're here now.
It's the going bald but growing a beard for me.
Ooh.
Hit it with that word. Hit it. Come on, word.
It's being in calc when you should be in algebra 2.
Yeah, there's no
It's the having a kid who's better at math than you.
Oh, that's funny. Oh God, I don't even know. That's my best one. That's the only one I got.
Dude, you're telling me you're running out of stuff?
No, I don't want to get too personal. I want to get fired.
Okay,
Nah.
I'll work with. I think all of us are gonna tattle.
What'd you get, Brady?
That's true. There ain't no snitches in this room. They all hate me.
That's funny.
You were X plus 4, X minus 4.
Was.
Pass. Because you got 3 extra.
Wait, is there no inflection points for that one, Jamie? That's 0 positive.
Oh, I was looking at that.
Where is this one?
You're a target.
So yeah, that's not real bad.
You find any inflection points?
How do I do it? How is this one working?
You absolutely do not.
Yeah, that was 0. This is, and then this one you would solve it.
Is that
Doesn't matter. This one's only. Wait, let me.
It's a strength that's gonna get Jared.
I know. I just wanted.
It's a plus and a minus 3.
Just let me look at that. Oh, that's disgusting.
Plus, now you use the verb of the second. You have to do that at Paul's tomorrow.
You missed it.
I will.
3e to the 3x.
He does that.
Times 4x.
How do we start?
Because it's the root of the front, times
You
second,
ever heard
plus
that song?
the second.
What?
Times the front.
Oh, what?
Oh, is this
Oh,
right?
that's
No.
so-
Yeah, you can factor
This
it.
is so
How do
exaggerated.
you factor this?
No, we got them down. You got e to the 3x, and then got
Yeah.
Factor that out.
So a critical point would be 0.
Wait, have you done this one yet?
How do I factor?
How do you normally factor?
I take like a 3
I
out.
also listened to.
What do they have both in common? There's a plus sign in between.
Wait.
So what do they both have?
So then
She's a big
they
girl.
don't need a star.
Yeah, and
There you go. It's stuck in
pull
your
that
head
outside of
now.
a parenthesis and write down what's one.
So I can have
How's it 3? So do I
whatever point and that of the same value.
Or times or add them? Oh, you should take
Those are, so whatever's on the outside, those are multiplied.
Braden.
Yeah.
Give negative.
Or- How do I
First
derivative that? Oh, that's terrifying.
Dude, the problem is I can't
I know. Are you on a different one?
Oh gosh.
I was listening to that Pitch Perfect mashup.
It started with this.
Where it's
So I just that. That's 0.
Through some shot.
Fuck, perfect. Didn't even that hurt.
And then at the same time, there's another chorus that comes in and goes.
So we ignored this? I just ignored it. So it's 0 and that's 0 and 0. That's probably one of the hard ones.
Yeah,
0
0
and
and
0.
And
I don't know.
I'm on the natural log.
You know how to do it.
I
I did the
it's still a part of it.
x squared minus 9 to the 7th. I did that
Oh, I
one.
did that one. Did you get 0 and 3?
0 and 3
Back.
negative.
Okay, so is that right?
Negative 3?
Because it's a plus minus plus 3. 3 minus 3.
Be a
you get
1
negative.
plus, yeah. And so then what you do is you set, so that's 1 plus 3x, right? So then you can figure out what would make this thing equal 0.
Lord, why is there
And
an
then you
E
figure out
right?
what that thing
And
could
an
equal.
LNX?
So is it just 0 for this one?
X plus 3.
No, because you plug in a 0, that would make it a 1. So you'd actually have to set, that, what's the thing on the outside? It's e to
So
the,
when it's minus or
right?
minus, does that mean
You have to set this equal to 0 and you actually have to solve, right?
I'll do that.
E to 3x is 0.
So what's the
So could it actually be 0? Could there be any number I plug in here that would make this thing 0? I don't think there is. I don't think there is a number I could plug in there. So you would, because if I did the natural log,
You get a haircut?
Because
It's the back is so clean.
I don't think I can write that. I don't think. Do you have a calculator? What? I don't know if natural log of 0 exists, so that might not actually have a 0 to it. So that might not actually.
That's inflection points now.
So
So the other one
That
is
counts
0
out
because
as
it's
X
why
max.
does it go
That's a
0?
plus minus
Ryan, doesn't Eric look hot? Like no homo?
this is your other one, right?
Put over
And then
Oh, I forgot the one.
Yeah.
for Erica.
No, I was talking about Eric. Erica, like Mr. Warren, 4 out of 10. No, I'm kidding.
So is it 1 over
I'm like, I can't believe she said that
Minus
I have a
five.
boyfriend.
Mr. Ward,
Like,
you can inflection
Travis
points
Street,
twice.
you have a
And
boyfriend.
then bounce, so you just write it.
I don't
There's
know.
no-
Yeah, just write down. I don't care about
Well, you're
balancing
asking
and
for
passing
another
through.
man's sausage.
I just want to see what the different numbers are.
Okay, now how do I find the second derivative?
So second derivative, Travis, you go to gentlemen's. Okay. So this one.
Yeah, I
do
Oh,
product
stop
rule
going.
again,
Stop going. I'm gonna grow it out.
and product rule
That's
again.
the
you
first
have
one.
And then I'm gonna
Right.
cut it.
So it's just like what you just
7
did.
x squared minus 9 to the
What do you do
6
after this, Isaac?
minus 2x.
Now again, we are going to talk about these. I said there was two that were kind of tricky. I think.
I think I'm doing
Are those the logs?
No.
Yeah.
Okay.
The point is actually
How do you do it? Doesn't
How do you
matter.
find the
I just do it
derivative?
because I gotta find the inflection
E.
points of 2 equals.
Yeah.
Squared minus 8x.
E to the 3x. That's derivative of E is E to the 3x, and then you take it times the derivative of what the power was.
Yeah, 3x plus 4 and 1x minus 4.
So it'd be 9
So it's 4 and
e to
negative
the
4.
3x.
I hate that one.
Will you come see if I'm doing this right?
Yep.
Then do the second derivative, which is minus
You
And then
didn't
you
tell
have
us
to
about like any of these
product
weird
rules.
ones.
I did two, I warned you.
Times back derivative.
Yeah, you didn't tell us how to do
Oh my
them.
god.
Get a mouthful of meat.
find derivative.
That's all
I
that.
do not.
We did this whole last semester.
You're acting like you're acting like I remember. Okay. How do I do that? Isaac, come here. You wanna rub my rock hard belly?
Just go away. Where'd your 14 come from? You didn't multiply by 2?
I get into a different level of class.
When you do the natural log, it's just 1
I'm
over
in
x.
love. I didn't know that. Why would I know that?
Have you done this one, Jamie?
Have you done the
No, you have that symbol right
squared minus
It's just, the answer is 4 is not 3/4.
No, I think like drop it out front, right? It's more
and then negative.
Take the
I
derivative.
think I am going on. It's a long day. Oh.
So in other words, yes.
I'm confusion
on.
Wait, you only know the
I have minus 4, which is.
What do I, so do I just stop here?
Oh, no. You don't need
the last
3x.
one.
You don't need it.
Just the middle?
You don't even need it.
Right now, I'm trying to figure out what E is.
So you have 4/3, negative 4, and then you have 0 and 4/3.
No, I said this one equals 0 for the second. Oh, yeah, it says the same.
So it's,
Sorry.
we gotta do the inflection point.
And then multiplying them, don't you do it?
Third.
Yeah, you can just leave it at
So it's
Wait, product rule probably.
for 9.
How do you
No, that's what you're wrong.
factor this?
Running and subtracting, we just, yeah, running and subtracting, we just did it independently. Eric, did you figure out that one yet? Jared?
Working on it. So it looks like everything has 3x.
Yeah, so that's just, yeah, this one we just do.
Well,
Starters.
starters.
So
So that's like a 12.
But this one-
This is like a 36. X e to the
My
3x.
next one is the
12
5x.
I have to simplify for
That's my next one.
How do you start the natural is to?
Natural log.
It's 1 over.
It's just 1 over whatever that thing was.
Okay. So 1 over 3x.
No, it's 1 over x and then the 3 x.
So
For the.
remember the front.
So that's what.
Oh.
So
Plus 5x.
Yeah, plus 5.
So it's times the derivative of x.
The square
That's
root of
still
9,
there.
that's 3, right?
Must
And that's, these are being.
So it's plus 3 minus.
So I can put it 3 over x.
And then we can use the solve to do on the back. Just solve set equal to 0 and solve.
Simplified version.
So I go plus 3
Would you like
minus,
to
and then I do.
help me with that?
So
I don't know.
negative 5 so e to the 3x to get, okay, 0.
This one,
You have to do natural log of 0 over the natural log of 3x. What is the natural
So
log
you
of
multiply the
0?
x over.
Do you multiply the x over? Error.
I multiply the x over. You multiply the bottom over. And then
oh, so I just flip the two numbers around.
So it's negative 5x exists, then divide by negative 5.
This is what I'm doing, right?
Have you done an x to the third?
I think it's the natural log.
Yeah, and a couple of these you have you have x on one of these, didn't you?
Have you done an x to the third minus 8?
An x there, so there's an x there.
I don't like
Wait, how do I add
36.
it? How do I add an X on this? Just
So
How?
the derivative of natural log.
Oh wait, that's a 0. That's a 0. How do you find a second derivative?
Well, because x tends to
So
0.
you simplify to multiply that 7 on the
E to the 3x, what does that mean? That's irrelevant.
and then do
But now he's gonna do
a,
a 3x of
So,
a quotient or do a product rule. I don't think you have to go second derivative on that one. You just have to do critical points. You don't have to do inflection. Hey, make sure some of those questions say just find critical points. You didn't have to go inflection. You didn't have to go second derivative on some of them.
Let's go! How do you find the second derivative?
Let's go!
So then this would just be like.
Zero. Yeah, look, he doesn't count. Doesn't count. Yeah,
So what
so
kind
that
of
thing
point
equals
is
zero
one?
and solve that.
How do you find the one through point? I said second derivative.
That one, so,
Zero.
rule, you can, it comes down to
4x.
Isaac.
It's
Why can't
a-
it be zero?
No, not
So,
zero.
Cool.
you have to say zero, or,
Zero is not.
Well, I have
take the
Ellen.
denominators, add together, you equal.
X under 5?
Yeah, so, 5x over x.
I don't know how
I get ADHD so much in my class, I get like enlightened.
How do I just add an X?
You're putting x on top and bottom. Make it complicated. It's like 5 over 1. So it's 5x over
X
x.
over 5?
That's 5x over 1.
This one's over. That doesn't make any sense. Are you talking about this tomorrow?
Brayden, this is what you're doing, right?
Let's go to the shop. Yeah.
Gotta put a 1 down here. Make it a fraction. To add these two together, you have to get common denominators. So I gotta multiply by an x, so I have to multiply by an x. That's how you get common denominators in fractions. Now I can add straight across.
So it's
Come down to the top.
X over
Come down to the top.
I'd love to, but I have
3x plus 5x or 3 plus 5x.
Yeah, and then just do your quotient.
Hey, I'm going to the shop too.
What does this do?
Right.
So we'll do it tomorrow?
Yeah, we're gonna go from 7 months.
Oh, that sounds bad.
Classroom.